This is the fourth video in a chapter on essential ideas in chemistry. We are continuing our talk about measurement and uncertainty. And in this video, we'll talk about dimensional analysis. So we introduced all of the standard units for measurement, and sometimes we need to convert between those units. And the fancy name for unit conversions is dimensional analysis. And dimensional analysis is basically just using a multiplication factor to change a unit. So the way this is going to work is you are going to have some unit. Perhaps you have a unit of seconds. And you're going to start with that number. And then you're going to want to multiply that number and that unit that you have by a fraction. And you want that fraction to have two numbers in it, one number that has the same unit as the one you have, and one number that has the unit of what you're trying to get. And we're going to put the number with the unit you have on the bottom. And the unit that you want on the top. And if we do that, we can cancel units in the same way that we can cancel numbers. So if we have the same number on the top and the bottom, they would cancel. And so here we have the same unit on the top and the bottom, so they will cancel. So the old unit, the one that I had, canceled with this new multiplication factor, leaving just the unit that I want. So I get some other number z that has the unit you want. And that's all it is. So all we have to do is find fractions like this to use. So a fraction like this is called a conversion factor that we use to change the unit. So we said units can be multiplied and divided just like numbers. We'll use that to our advantage to change the unit. We can't measure everything in meters forever, after all. And so this tool that we introduced that we're going to use, that's called a conversion factor, which is just a fraction. It has two different units, one on the top and one on the bottom. So these conversion factors, they can relate to different prefixes like we did before, like microseconds and milliseconds. Or they can relate to different units altogether. So let me show you an example of what I mean. So we did an example on the last page. We said that 1 microsecond is equal to 10 to the negative 6 seconds. And that was secretly a conversion factor. We just didn't write it in the form of a fraction. But we can do that now. So we can say 1 microsecond is 10 to the negative 6 seconds. And that is a conversion factor that we can use. We can also use the conversion factor in its upside down flipped version. So we could use it as 10 to the negative 6 seconds in 1 microsecond if we wanted. We can choose which one we need based on which unit we need to have on the bottom. So those are converting between two different prefixes. We can also convert between two units altogether. Let's say we wanted to convert between seconds and minutes, which are different units of measurement for time. We know that there are 60 seconds in 1 minute. Or if we wanted to convert in the other direction, 1 minute is 60 seconds. So all we need to know is how many of one unit are equal to how many of the other unit, and we can create a conversion factor and flip it upside down if necessary, so we can use it. So let's do an example. You can see that I've already written the examples out ahead of time. You can take a moment to copy those down now if you would like to. So for our example problem, we want to convert 700 microseconds to seconds. So here's our procedure. We're going to start with the number and the unit that we have. So we have 700 microseconds. We want to know how many seconds. So we'll start with 700 microseconds over here. Now we want to multiply it by a conversion factor. And so we want that conversion factor to have the same unit as we started with on the bottom. So we want to have microseconds on the bottom and the unit we want on the top. So we want to find seconds, so that goes here. So we can plug in the units first. Now we need to figure out how these two things are related. And if you remember your prefixes, you'll remember that micro is 10 to the negative 6th to every 1 second. Oh, you can't see that. There we are. There's 10 to the negative 6th microseconds in 1 second. So 10 to the negative 6th microseconds in 1 second. That doesn't sound right. This is going to be 10 to the negative 6th seconds in 1 microsecond. There we go. So if you make this unit be smaller and smaller, you get to the smaller unit. You always have to make sure that our units make sense. All right, and then we'll do our calculation. So 700, and we'll multiply it by 10 to the negative 6. So we can use this little 10 to the x button above the log, 10 to the, and then we put in the exponent, negative 6, close the parenthesis. We got 7 times 10 to the negative 4. And then when we want to check out the unit for the answer, we can see that the microseconds canceled and we are left with seconds. And then we can check to make sure that our number is reasonable, because a common student mistake is to mix up where to put these two numbers, as I have just done. So what we want to check is that if we have 700 microseconds, this is probably smaller than 1 second. This is a really, really short amount of time. So as we go from a small unit to a big unit, the number should go from big to small. So our number went from 700 to 0.0007, so the number got smaller. So that one passes the bullshit test, and we'll take that answer. So we used one conversion factor to make that conversion. For the next one, it's not going to be quite as simple, so we're going to need another trick. And that is, we're going to need to use multiple conversion factors. And they can be used in a row. So you can do each conversion as one step, or you can just do lots and lots of conversions in one long multiplication row to reduce the number of times you have to use your calculator. So let's try the next one. So convert 700 microseconds to minutes. So the number that I'm starting with is 700 microseconds. So we'll put that first. And the number that I want to know is minutes. So I need a conversion factor, and I don't have a conversion factor between microseconds and minutes because these are not in the same unit. One of them is in seconds and one of them is in minutes. So what I'm going to have to do is use two conversion factors, one to convert to change the prefix of microseconds to seconds, and one to change from seconds into minutes. So here's what I mean. I know the relationship between microsecond and second, and I know the relationship between second and minute, so I can do it in two separate steps. And I'm going to make sure to put microsecond on the bottom of the first one so that it cancels with our starting number, and seconds on the bottom of the second one, so that cancels with the numerator of the first unit conversion, and we'll end up with minutes. Okay, so we're going to get the conversion factor right the first time this time. So we have 10 to the negative 6 seconds in 1 microsecond. So the bigger unit has the smaller number with it. And then we set up here, there's 60 seconds and 1 minute. Okay, so when we multiply through on this one, we're going to multiply the numbers first, and then we'll multiply the units second. So we're going to do 700 times 10 to the negative 6 and divided by 60. Going to make sure we don't forget any of our numbers. So we've got 1.1666 10 to the negative 5. So we'll shorten that 1.2 times 10 to the negative 5. And then we'll do our units. So microseconds cancel, seconds cancel, and we're left with minutes. And then we do our bullshit test to make sure that this makes sense. 700 microseconds is a very, very small amount of time, so we expect it's going to be a very short number of minutes. And this is a very, very small number of minutes that we ended up with. So we'll take that. We always check to make sure that our answer makes sense when we get to the end. Okay, so what we did here was we had to use multiple conversion factors, 1, 2, and we used them to convert the same unit. They were both converting the time factor into a different time factor. But sometimes we have to use multiple conversion factors to convert multiple units. And this next example will show you what I mean. So in this example, a bicycle is traveling at 8.4 miles per hour, which is a unit that has 2 different units inside of it, both miles for distance and hour for time, because this is a rate. How fast is this rate? In kilometers per second. And here I've provided you with the conversion between miles and kilometer. So this is a much more complicated dimensional analysis problem than the one we just did, because there's 2 different units, but I think we can handle it. So we always start with the units that we have. So we have 8.4 miles per hour. And when it says per, that's indicating it's being divided by. So that's 8.4 miles in 1 hour is the formal version of that number. We are looking for how many kilometers per second. So that's kind of like where I hope we'll be at the end of this process. In order to change from miles per hour to kilometers per second, we have to change both the units of distance and the units of time. So I like to change one of them at a time. So I'm going to do distance first because it's on top. So I'm going to put in a conversion factor to change between miles and kilometer. So I have miles, that goes on the bottom. I want kilometers, that goes on the top. And I can see that that will help this miles to cancel, and it will leave this kilometers at the end like we want. And we have our conversion factor here. It was listed in the problem. 1 mile is 1.6093 kilometers. Okay, so now we have successfully reached this part of the unit that we want. So then I'm going to convert the time units. So I have hours and I want to have seconds. So if you know the conversion, the number of seconds in an hour, you can go straight there. I don't know the number of seconds in an hour off the top of my head, but I do know the number of minutes in an hour. So I'm going to convert this into minutes, and then I'm going to convert minutes into seconds. So I'm going to put hour on the top of this conversion factor, so that hours cancels, and I put minutes on the bottom. And so then for my next one, I put minutes on the top so that the minutes in the previous conversion factor cancels. And then I'm left with seconds on the bottom, just like I wanted. So this should provide me with kilometers per second. And then we can put in the number of minutes in an hour is 60 minutes in 1 hour. The number of seconds in a minute is 60 seconds in 1 minute. So now we are ready to multiply. So if you use your calculator, you should reach an answer that I don't have room to write. We're going to write it up here. 3.8 times 10 to the negative third. If you do 8.4 times 1.6093 divided by 60, and then we can cancel our units to give kilometers per second. There we go. So we had to use 3 unit conversion factors here. One of them we used to convert length, and 2 of them we used to convert time. So dimensional analysis to convert unit will work for every type of unit that we had over here: length, mass, time, current, amount, light intensity. The only one it doesn't work for is temperature. So temperature is the exception. We cannot use dimensional analysis for temperature. So I will list the temperature conversion formulas here. while we're talking about it. So the standard unit that we use in America to measure how hot or cold something is degrees Fahrenheit. And the standard unit that we use in chemistry, we will often use degrees Celsius. So we can convert between that by taking the number of degrees Fahrenheit and subtracting 32, then multiplying that number by 5/9. That will give us the number in Celsius. And then if we want to reach the standard unit that we use internationally, we need to convert to Kelvin. So we take our temperature in degrees Celsius and we shift it up by 273.15. And that gives us the temperature in Kelvin. So for long and difficult reasons that we don't need to go into, you cannot simply just multiply by a conversion factor to change the temperature. You need to add and subtract. So you will need to use those formulas to convert for temperature. So that is everything you need to know about the unit of a measurement. In the next video, we will talk about the uncertainty associated with a measurement.